Alright, so this is a check your work video. I really hope that you decided to try the work before you came and looked at this video. I'm not going to know either way, but it's better for you and your brain if you did. So let's go ahead and look at number 5 first. Taylor writes an expression with 5 terms. I'm going to highlight this. This is important information right here. With 5 terms. All 5 terms are like terms. Again, important information right here. How many terms are in the equivalent expression with the least number of terms? Explain. So least means the least amount, means the smallest amount. If I have 5 terms and they're all like terms, this is kind of a trick question. Okay. So let's go ahead and look at this. I have 5 terms. Remember, terms are, let's just say I had 5, 6, 8. Whoa, that 8 is wacky. Sorry. 11, 2, 1, 2, 3, 4, 5. Okay, so I have 5 terms here. They're all like terms. Why? Because they're all numbers. There's no variables involved. You could do this as like x, 2x, 7x, etc. It doesn't matter. It doesn't say what your terms are. It just says that they are like terms. Okay. So if they're like terms, they're all like terms. All 5 terms are like terms. That means that they can be combined. So if I combine all these, how many terms are going to be left? Well, let's just say 5 plus 6 is 11, plus 8 is 19, plus 11 would be 30, so this would be 32. So let's just say I added all of them. Sorry, I didn't put enough space between these, but I'm adding all of them. And it doesn't matter what you're doing with them, because if I were to subtract these all, I would still end up with only 1 term. So this equals 32. Now, if I see that you used this example in your answer, then I'm going to know that you didn't even try. You just looked at my video. But you should really try it on your own. Okay. And so the way that you would explain this is that regardless of how many terms there are, if they're all like terms, it means that you can combine them. So the least number of terms would be 1 term because they're all being put together. All right, let's look at 6. Carrie uses substitution to decide whether x squared plus x is equivalent to x times the sum of 2x plus 1. She says the expressions are equivalent. So she says that they are, because they have the same value when x equals 0. Is Carrie correct? Explain. So we're going to use her substitution to show whether these are like terms or not. Here's the problem with what she used for substitution. You cannot use 0 to show substitution. It just doesn't, it's not, because 0 is going to make everything equal. It's just going to make it 0, right? If I put 0 here, this is 0, this is 0. X, if this is 0 and I'm multiplying it to both of these values, it obviously is going to be 0. So you can't use 0. We could just use 1. 1 would work. So we're going to say, why is that so light? Hey, okay, we're going to say x x equals 1. So now we have 1 squared plus 1. 1 squared equals 1 times 1 plus 1. So 1 times 1 is 1 plus 1 is 2. So it equals 2. So remember, substitution just means that you plug in the number, whatever number you're using for the value of your variable. All right, and then let's do this one. So this is going to be 1 times 2, which is also being multiplied by 1 out here, or in here, plus 1. Alright, first we got to do what's in the parentheses. So we end up with 2 times 1 is 2, plus 1 is 3. We end up with 3 times 1, which is 3. Alright, now time to put on your thinking caps. Is 2 equal to 3? If I have $3, do you think I'm going to trade you for $2? Nope. So is Carrie correct? No. Now you need to explain why.